So we're at 3. Must be a rational explanation. Operations with rational expressions. Let's take a look at the warm-up. Okay. So to add 1/2 plus 1/3, they have to have the same denominator. So to do that, we're going to multiply 1/2 times 3 divided by 3, and 1/3 times 2 divided by 2. Well, 1/2 times 3 divided by 3 is 3/6, plus 1/3 times 2 divided by 2 is 2/6. Well, 3/6 plus 2/6 is 5/6. Let's take a look at number 2. In order to subtract 1/2 from 1/3, they have to have the same denominator. So we're going to multiply this by 3 divided by 3, and this by 2 divided by 2. Well, 1/2 times 3 divided by 3 is 3/6, minus 1/3 times 2 divided by 2 is 2/6. Well, 3/6 minus 2/6 is 1/6. All right, let's take a look at number 3. 3 just multiply. 1 times 1 is 1. 2 times 3 is 6. Number 4. Now when you divide by a fraction, you flip and multiply. This becomes 1/2 times 3 divided by 1, which becomes 3 divided by 2. All right, go ahead and finish up the warm-up. All right, let's take a look at the next page. Light the corners of my mind. In elementary school, you divided rational numbers using long division. You wrote the quotient first with a remainder and then as a mixed number. For example, 13 divided by 3 equals 4, remainder, and 13 divided by 3 is equal to 4 times 1/3. Okay? 1. How are the quotients of rational expressions connected to those determined in elementary school? All right, let's go ahead and use long division. So we ask ourselves, what do I multiply x to give me x squared? The answer to that is 1x. I multiply 1x times x minus 2 is 1x squared minus 2x. Subtract. When you subtract the negative, it becomes positive. Cancels. 2x and 2x is 4x minus 3. And then you ask yourself, what do I multiply x by to give me 4x? The answer is plus 4. And then multiply 4 times x minus 2 is 4x minus 8. Subtract. When you subtract the negative, it becomes positive. Cancels. Negative 3 and 8 is 5. So the quotient is x plus 4 plus 5 divided by x minus 2. All right, go ahead and finish up A. And then let's take a look at B. How do you know that x is not equal to is a restriction for the quotient? The divisor is x minus 2. With x equals 2, the divisor would be 0, which would make 5 divided by 2 minus 2 equal to 5 divided by 0, which is undefined. Let's take a look at the next page. 3.1. Calculating sums and difference of rational expressions. You learn that operating with polynomials is similar to operating with integers. Likewise, operating with rational expressions is similar to operating with rational numbers. Consider the table shown. All right, take a moment to read over the table. All right, so go and mark out 1A and B. And let's take a look at the next page. All right, go ahead and mark out number 2. And let's take a look at 3. 3A. Now, in order to combine these, they all have to have the same denominator. Okay, so I need to multiply 3/6 times. Now, we have to figure out what the common denominator is of 6, 4, and 8. So let's look at the combination. So we have 6, 12, 18, 24. Oh. 4, 8, 12, 16, 20, 24. And then 8, 16, 24. Well, 24 is the common number for 6, 8, or 6, 4, and 8. Okay. So this needs to be 24. So to do that, we need to multiply this by 4 divided by 4. We need to multiply this by 6 divided by 6, and this times 3 divided by 3. So this becomes 12 divided by 24 plus 30x divided by 24 minus 3y divided by 24. All right, go ahead and finish up A. All right, let's take a look at B. This is pretty straightforward. 12 is our denominator, so we need to multiply 3 by 4 divided by 4, and this by 3 divided by 3. Well, I have to multiply each term by 4, so this becomes 4x minus 8y divided by 12 plus 1x divided by 12 plus, minus 3z divided by 12. Now here we can combine terms, so we can combine the 4x and the 1x becomes 5x minus 8y minus 3z all divided by 12. Alright, go ahead and finish up B. And let's take a look at C. So here, 18 looks like it's our common denominator, so we need to multiply this by 3 divided by 3, this by 2 divided by 2. So that becomes 12x divided by 18 minus 4x divided by 18 minus 1x divided by 18. So 12 minus 4 minus 1 is 7x divided by 18. All right, go ahead and finish it up and mark out number 4. Let's take a look at the next page. 3.2, determining the LCD of rational expressions. When rational expressions contain variables in the denominator, the process remains the same. You still need to determine the least common denominator before adding and subtracting. All right, go ahead and look over the table. Go ahead and mark out A, B, and C. Go ahead and mark out this page. Go ahead and mark out this page. 3.3, patterns in rational expression differences. Consider the worked example. Go ahead and look over the worked example. Then go ahead and mark out and go to the page. The student works 6F, 6G, 6H, 6I, and 6J. And mark out 5. All right. Go ahead and finish up your notes, start working on the assignment, and have a wonderful Wildcat day.